Hi gang, so we're back working on some examples of divisibility rules, section 1.9. On the board behind me, I have an example. So this is similar to the exercise we'll be doing on page 23, question 1. So the number that I have is 12,150. Right here, so 12,150. And I want to find out, is this number divisible by 2? Is it divisible by 3? Is it divisible by 5? Is it divisible by 10? So I want to know, can 12,150 be broken up into 2 equal parts? Can it be broken up into 3 equal parts? Can it be broken up into 5 equal parts and 10 equal parts? And then if so, how many can we have? So I'm going to think about the rules that I found for divisibility. To find out if I can do 12,150 divided by 2. So what I'm trying to find out, 12,150 divided by 2. Is this possible? So I'm going to look, my rule for the 2 is that the last digit has to be a 0, 2, 4, 6, or 8, right? Any multiple of 2. So I'm going to look here. My last digit is a 0. So yes, I can divide it by 2. What about 3? Now 3 was the tricky one. 3. I want to know, is it possible to do 12,150 divided by 3 into 3 equal groups? So I can always divide something, but sometimes I have some left over. Sometimes I have some extra. They don't fit into exactly 3 equal groups. Now, can I do this one? For divisibility by 3, what did I have to do? I have to take each digit in the number, so 1, and I have to add it together. Plus 2, plus 1, plus 5, plus 0. So when I add these all up, 1 plus 2 is 3, plus 1 more is 4, plus 5 is equal to 9. Now the second step, so I know it equals to 9 now, this second step, can 9 be divided by 3? Yes, it can. 3 times 3 is 9. So here I know that 9 can be divided by 3. Therefore, this whole number can be divided by 3. What about 5? Can I do 12,150 divided by 5? Is it possible to have 5 equal groups? If you remember, our divisibility rule say that for it to be divisible by 5, the last digit here has to be either a 0 or a 5. This one here, it's a 0. So yes, I can divide it by 5. And finally, can I do 12,150 divided by 10? To be by 10, this is the easiest one. The last digit has to be 0. If it's a 0, you can divide it by 10. So this one here, this number here, 12,150, has a really interesting characteristic in that it's divisible by 2, by 3, by 5, and by 10. So that works out really, really well. Let's do another example. This time I'm going to take the number 71,360. Let's do 361. I have 2, 3, 5, 10. So, in order for it to be divisible by 2, I look at the last digit, and it has to be 0, 2, 4, 6, or 8. So, no. This number cannot be divided into 2 equal groups. I will have 1 left over. What about by 3? So I'm doing it by 3. I'm going to take each individual digit and add it together. So I'm going to do 7 plus 1 plus 3 plus 6 plus 1. 7 and 3 is 10, plus 1 is 11, plus 1 is 12, plus 6 is 18. 18. Can this be divided by 3? Yes. 6 times 3 is 18. So because my answer to the sum of all my digits can be divided by 3, 71,361, that whole number can also be divided by 3. What about 5? For it to be 5, the number has to be 0 or 5. I have a 1, so nope, can't be divided by 5. And for 10, it has to be a 0, so nope, it can't be divided by 10 either. Now, on the next page in your math book, you have a chart, a Venn diagram on page 24. So I'm going to show you that quickly. So here on page 24, there's a diagram that looks like this. After that, it looks like this. And then down here, it looks like this. So I have 3 different ones. So this one here, you can divide it by 2. This one here, I can divide it by 5. And this one here, I can divide it by 10. So in fact, I'm going to take it, so if I divide by 5, I'm going to do in pink. That's divide by 5. And my divide by 10, I'll add some purple. Hopefully you can see that. Divided by 10. So now the Venn diagram, I'm going to put up a number, and I need to decide if it's going to be divisible by 2, by 5, and by 10. If it's divisible by only one of them, I'm just going to put it in that section here. If it's divisible by 2 of them, example by 2 and by 5, I'll put it where the 2 cross over, where I have the white and the red where they cross over. Or if it's divisible by 2 and 10, I'll put it in here. Or divisible by 5 and 10, I'll put it here. And if it's divisible by all 3 of them, I'll put it right here in the middle. So let's take the first example, 1,475. 1,475. Is this divisible by 2? I look at my last digit. No. Is it divisible by 5? Yes, because my last digit is a 5. Is it divisible by 10? No, because it's not a 0. So here, I'm going to write my whole number. 1,475 is just divisible by 5. If I take my next number, 2,300, same process. Is it divisible by 2? I look at my last one here. Yes, because it's a 0. Is it divisible by 5? No, because it's not a 5. Or, sorry, yes, because it is a 0. Sorry. Yes, it's divisible by 5 as well, because it ends in a 0. And is it divisible by 10? Yes, because it ends in a 0. So here, right in the middle, where they all connect, so I have the part of the blue, part of the white, and part of the red, 2,300. Now, I probably want to write a little bit smaller in case there are more numbers that will fit in here. 0. All right, 2,300. And if you were to come up with a number, example, 2, 10. No, I think that's it. So if you were to come up with one that's just 2 and 10 and not 5, it would go here. If you had a number that was 5 and 10 but not 2, it would go here. If you had a number that was 2 and 5 but not 10, it would go up here. So that's how you work on question 2 in your textbook. And you should be able to figure out the rest. So good luck.